Hey class, it's Nick, and this is part 2 of the final project video for computational methods. And I've got our friend Mr. Bunny over here, and I'm going to be talking about how to go from the contours to the actual waffling. And the waffle effect, as you can see here, is basically that I'm going to cut a notch in the front face of one set of planes and a notch in the back of another set of planes. And there are different methods floating around for how to do this, but they don't work very well most of the time for irregular shapes. The method that you're going to do is going to allow you to deal with geometry that doesn't have a consistent cross section. For instance, our bunny kind of goes out and goes back. It has a very thin part up here. It has these two pieces and one piece here. So some of the basic methods of waffling that kind of assume a more regular shape aren't going to work. What we're going to do is basically we want to look at the size of one of these pieces, and we're going to move our cross section, basically the piece that we're going to use to make the key joint, half of that distance, and that'll keep this locked to the size of the object. You can see here, so it's kind of halfway through here, and halfway through here, and halfway through here. And we'll do the same thing with the other cross sections as well. So we're gonna utilize the size of the object in the calculations for how to create that finger joint. And because it's smart in that way, it's gonna basically allow us to have a better object. And you'll probably notice actually these are not quite lined up. Really, the way the object is supposed to work here. Let me move these over. Would be like this, pretty much. I just did this for illustration purposes. But you can see there, that's what it's going to look like, basically. And you'll get little, pieces like that. You'll just kind of throw those away. No big deal. I didn't really cut enough cross sections for this to really do a good job, but you can see how it kind of approximates that form. Okay, so how do we do this script? Well, you're going to start from the last script that we talked about with your cross sections. So hopefully you figured out how to create cross sections in your two axes. In this case, I have Z contours and I have X contours. You can see the compass rose here. The next step that you're going to take is you're going to create boundary surfaces. Okay, and a boundary surface is basically if something is planar, it can basically become a surface. Okay, so it's a two-dimensional. It has no thickness, and the reason you want those surfaces is because you are going to take the intersections of those. See the green line here. So where these two things cross, you are going to get a series of intersections, and that will actually become the basis of those key joints that I talked about. So there'd be a line here, and we are going to create an object on these intersections that's going to be used to create that joint. And the same line will be used for the Z sections and the X sections as well. Okay. So you'll put those boundary surfaces together, being mindful of the data structure. It's because you're going to be crossing one object with multiple objects, you're going to have to graph one of the lists in order to actually create the piece you want. The other thing that you're going to do is you're going to want to clean that data. So there's a component that's in Grasshopper that's called data clean. And if you go into sets tree, you are going to, actually I guess it's called clean tree. Okay. And what you do is you'll plug your list in to clean it, and you're going to remove any invalid items, so that's true, and you're going to remove any empty branches. That'll also be set to true. What that'll do is just basically sanitize the data. You're going to get a few things in the intersections that are not, you just don't want. When you're done, you go ahead and flatten that list. Okay. Moving on. So if we look at our object, we're going to end up with a series of intersections again, but it's just going to be a nice clean list. What we're going to do with that is find the endpoints of those lists. Okay, and we're going to use those endpoints basically because we want to figure out how long they are. Okay, and so we'll take the endpoints and we will get the distances between those. So you'll plug in the endpoints to find the distance. Okay, what we're going to do is basically make a set of boxes. So center box, okay, that are going to go along those. So you have got this number, that's the distance. You can plug that in for the, well, basically, actually, before we do that, what we want to do is, since it's a center box, we actually want to find out the centers of the lines. So you want to find the midpoint of all of these intersected lines. Use that to plug in your box. Okay. Then you want to, so the finger joint needs to be, the width of the finger joint needs to be the width of the material that you're using. So you're going to plug in the material width into your box component, right? That'll be the x, the x-axis. Okay. The y-axis just needs to be deeper than the material that your piece is made out of. And so if we were to take our surfaces and extrude them, and this is just for, you don't need to do this, but I'm just demonstrating this to you. Oh, actually, well, this is not quite accurate, but you can see our object just needs to be, the box that we create just needs to be deep enough to penetrate that, because we're going to use that as a boolean to actually create the finger. Okay? So if your piece is, 32nd of an inch, this dimension, x wants to be 32nd of an inch, this needs to be at least a 16th of an inch so that it exceeds that that dimension. Okay, you want to penetrate the top and the bottom. And then the last piece, the length of it, right? In this case, the y-axis is going to be that distance that you calculated from the endpoints. Okay, and that gives you your boxes. Okay, you might need to add some mathematical sliders in there in order to get the proper distances and things in there based on your parameters. But that's the procedure for making these. What we're going to do with this is we're going to move it half of this distance so that you end up with this. Okay? Then you are going to, as I kind of showed earlier, I think what you're going to do, since it's centered, it's impossible to we want to extrude this, but we want it to, when it's done, to be in the middle of this line. So what you can do is move it down half of the distance of the material thickness, and then extrude it the whole distance of the material thickness. Okay? So if we can do, like, we'll do this, or move it up, I suppose. And then you can extrude it, and that will actually give you that full material thickness. Okay? Once you have both your pieces of material and your fingers, you're going to go ahead and plug them into a solid difference component, and that will give you your boolean pieces. Then you can bake these, and this is half of your thing. I'll go through quickly the process for the other side of it. Go ahead and turn this off here. Turn my points off too. Okay, so if we go all the way back to our boundaries and our intersections, okay, we're going to repeat the same step. We're going to make a series of boxes, but in this case, we're really only interested in this plane, okay, the z-plane. So the thickness of the material is going to be the z, and the width of the material and the x has to penetrate both sides. And we're still looking at the length of it and y. And we'll go ahead and do that, and then we're going to again, move those keys half the distance of that object, right? And then boolean them out using a solid difference. Oops, wrong. The order of it's kind of important, so I think I've got a bug here. Okay, so once you've got that, you have these shapes, then you can go ahead and bake these. Okay, and those are going to be pieces. Okay. Now the issue that's going to come up is that once you distribute these pieces to your cut sheets, is that they are not going to be flat. Like you've created them as solid geometry. Okay, so once you distribute them to your cut sheets, using the method I talked about with the orient command. So again, I would draw a surface and find the planes on it. It's going to allow me to distribute those pieces. Anyway, the issue with this is going to be that they're actually geometry. So once you've got those pieces distributed, the issue is going to be that they are solid pieces of geometry. And again, this is the distribution method that I talked about. Having a surface, you get your frames on the surface, and you get your frames that are oriented, to your objects, and then use the orient command to distribute them. Once we've got those objects, though, they are not going to be flat pieces. We can't cut these as they are. We need to make them flat. Okay. So in order to flatten it, a technique that works that's not too convoluted is to basically take and create a plane that is going to intersect that object, and that plane is actually going to be centered like halfway. You can see that. It's kind of hard to see. Let's see if I can make this clearer for you. So, see the green line here? So it's actually halfway inside the object, and then that's going to ensure a clean like intersection. And then once we take the intersection of those two objects, you'll basically get that flat curve. Okay, so just to take a plane and essentially just use it to do like a Boolean like intersection. Okay, and then this will be nice and like bakeable. You can put a label on it, and then that'll be on your cut sheet. So let's go through that technique. I'm just going to focus on the one object, not all these objects, but the technique will certainly apply. So the first step that I'm going to do is just start with a bounding box on this object, and the bounding box is nice because it's going to give us just two things. One, it gives us a plane that's perfectly sized to the object, and two, it's going to allow us to look at the height of the box. And if we take half of that height, then we can position that plane exactly halfway, so it'll make a perfect intersection. Okay, so I'm going to take a bounding box, and we use the box corners. You can see my 8 corners as we've done before. So just like what we did when we first made sections on the objects. Okay, from the box corners, I'm going to take the first 4 corners and use those as the basis of a 4-point surface. So if I plug in the first 4 corners, then I get a surface that's perfectly sized, okay, to the box. Then to that, what I'm going to do is I need to move that surface. So what I want to do is I want to find the distance, use a distance component, and using the first and the 5th point, let's say on the box, A and E, find that distance, find half of that distance, and then move my plane half of that distance in the z-axis. Then if I do a B-rep to B-rep intersection, it's one of the components that you have, a B-rep to B-rep intersection between the plane and the object is going to give me the curve. Okay, so you do that for all of your pieces, and that's essentially going to allow you to make all the pieces you need for your cut sheet. Okay, so again, from there you just add labels and cut your waffle, and you're done. Okay, so that's the end of the waffle part. The next part is going to discuss what to do with the facet part.